So this lesson is mechanics, chapter 4.5 about tilting, continuing from moments, the last bit about moments, which we look into tilting. You've got to carry on with the method that you've learned last lesson about setting resultant force up. So resultant force equals 0. So upward force equals downward force. And the second step, which is resultant moment equals 0. Now, we're going to add in a little extra bit. Last lesson, you learned about when the body is not uniform. When it's not uniform, it means the center of mass, the weight of the plank is not right in the middle. Right. So today, adding a bit of extra thing, which is called tilting. So what does that mean? Well, on the left-hand side, we've got two water bottles, okay, and on top, imagine it's a ruler, okay? When you place a ruler on top of two same water bottles, same height, everything, it's balanced. So you've got RA, reaction A, and reaction B in here, right? Supporting it. So the weight of the ruler, so let's put W. So this is balance, equilibrium, means, it's not moving, everything is fine. So in this one, RA plus RB will equal W, right? And the moments will equal the same. The clockwise moments equals anti-clockwise moments. But imagine now you move the ruler slightly to the right. Sorry, I have to color this one. Imagine you move the ruler slightly to the right-hand side. Now what will happen then? The ruler will start to fall. But imagine you put the ruler to the right just enough so it comes off A. So you can see it lifts off from A. There's some space between the ruler and A. And then it's on B. Now it gets a bit wobbly, but it's not falling. Okay, can you imagine that? You can try to do that at home if you have got two cups, two mugs of the same height, etc. Just place a ruler on top and try to move the ruler slightly, ever so slightly, to the right hand side, bit by bit, and then you see at one point the ruler become a little bit wobbly. Okay, but it's not falling. Now what happened here is then the RA becomes 0 Newton because the ruler has lifted off from A. So there's no more support from A. But there is reaction from B, and still there's weight from the ruler. So in here, your RB will equal W. So there's no RA at all. Now, in this moment, we still talk about moment, not pun unintended. We're still equilibrium, okay? Even though it's wobbly, but the ruler, is still hanging on B. It's not falling. So it's equilibrium. So moments will still anti-clockwise moments equals clockwise moments. But when it's tilting about B, RA equals 0. So when it's tilting about B, your RA equals 0 Newton. All right, let's move on. So example in here, a uniform beam AB of mass 45 kilogram. We love the word uniform because not as a kid, but uniform means the weight is right in the middle. Okay, so one less thing to care about. So maybe we can start to draw in diagrams. So we know the 45G is right in the middle. I like to use different color for the distance. So that's 5, total 60 meters. That means that must be 3 meters in here, and this must be 6 meters and 2. Yep. Okay, so because the whole length is 16 meters. Rest horizontally on support C and D. So RC and RD, you've done this many times before, where AC is 5 meters and CD is 9 meters. When a child stands at A, a brat stands on A, has to disrupt everything. Okay, stands on A. The beam is on the point of tilting about C. That means we are sort of tilting like this. Now imagine what it means is if you can imagine a kid sitting on the left-hand side, what will happen is this seesaw or this plank will start to tip on the left side and it will be lifting off from D. So what it means is when a point of tilting about C, the RD equals 0 Newton. That's 0 Newton. In other words, we can ignore it completely. But the mass of a child, yes, the mass of a child, the mass is M, so mg. So remember the first step, upward force equals downward force. So the upward forces are RC, and that's it because RD is 0. Downward forces, mg plus 45g. Yep, so I left it like this. Maybe I'll put 45G in a calculator and work it out. So 45 times 9.8 is 441. So maybe I'll do that. So RC equals 9.8 M plus 441. It's really up to you whether you want to do that or not. Step 2, hopefully you'll be able to tell me what to do. Moments at a point. You can take moments at point A, point C, or if you want to take the middle point, let's say E. I wouldn't take moment at D because our D is already gone. So I don't really need to do anything about our D. So remember, when the point you take moments, you don't have to calculate a moment of that force passing through the pivot. So moments at A, if I take moments at A, I can ignore mg when it comes to calculating the moment. So I've got 2 moments to calculate. RC, which is moment equals the force times the distance. The distance from A to C is 5 meters, so 5 RC. And the direction would be anti-clockwise. You've got 45G as well. So the moment equals 45G times the distance from 45G to A is 14. So 45G times 14 is 6,174. That will be clockwise. So therefore, step 3, clockwise mums equals anti-clockwise mums. So clockwise is 5 RC, anti-clockwise 6,174. Simply divide by 5. You got RC equals to 1234.8. Now I can use equation 1 to help me. That's my equation. So that's my equation 1. So if I sub into equation 1, then I've got RC, or actually 1234.8 equals 9.8 M plus 441. Rearrange it. Minus 441 divided by 9.88 M equals 81. I must have made a mistake somewhere. Let's have a look. Actually, I must have made a mistake somewhere. Let me have a look. So RC equals, yep, so 45 times 9.8 is 441. Where have I made a mistake? Oh, sorry, I made a mistake there. I'm so sorry. So see, even I made mistakes. The distance from 45G to A is not 14, it's actually 8. So 45G times 8 is 3528. Apologies. This makes the video real, you know, that I'm actually doing on live. And part of my teaching is that I make lots of silly mistakes. So if there's one thing that you can say to others, that how are you a student of Mr. Fan? Well, I made lots of silly mistakes following his notes. Just to carry on, fixing my mistake, that would be 705.6, and obviously 705.6 minus 441 divided by 9.8, and that's 27, which is the correct answer. A kid has 81 kilograms, should go to see a doctor as soon as possible. Right, so 27 kilograms, more likely the kid. Yep, okay. Next one. Right, so continue to tilting. A uniform plank AB, this time it's not given a diagram, so we have to draw one ourselves. We happily do that. A plank AB of length 2 meters, of weight 20 Newton. Now, first of all, uniform, length 2 meters, weight 20 Newton. Weight 20 Newton means there's 20 in the weight, not 20G, 20. Resting on support C and D. So the uniform plank AB has a support C and D. So where's the support? Let's say here and here. I don't know where it is exactly. So 2 meters. So hang on. So 2 meters. The weight is 20. So the weight is 20 right in down the middle. And I know that's 1 meter. Same with that one, 1 meter. What else? C is 40 centimeters away from A, so that's 0.4 meters. That would be 0.6 meters. And D is 60 meters away from B, so that's 0.6. That's 0.4. Support C and D means there's a RC and RD. Fine. the reaction force at each support. So we will find RC and RD. Now, they do not mention anything about tilting anything because that's part B. So if they don't mention anything, you just do normally. First step, upward force. So question A, upwards equals downward force. Upward forces are RC and RD. Downward forces, just 20. So step 1. Step 2, moments at a point. Take moments at, I'll probably take moments at C. So I can ignore RC, ignore one force. So I just have to calculate two forces, RD and 20 Newton. For the RD, moments equals RD times the distance. From RD to C is 1 meter, 0.6 plus 0.4 is 1, so it's just 1 RD. And the direction will be anti-clockwise. 20 will be moments equals 20 times the distance will be 0.6. That's quick maths, 12. And that will be clockwise. Step 3, clockwise moments equals anti-clockwise moments. So RD equals 12. So if RD equals 12, using equation 1, RC would have been 8. So 8 Newton, 12 Newton. Yep. All right. That's question A, done. Okay, fairly straightforward. And part B, a cat has to be a cat, doesn't it? Okay, has of all the animals, of all the pets, has to be a cat. A cat of mass 40 Newton starts from the center of the plank and walks towards A. Truth is, I'm also a big fan of cats, dogs. If you know, I've got 4 rabbits, but I actually like them. I love pets. I'm not, yeah, you know, cats are just fun, but I prefer dogs. A cat of mass, so walk towards A. Now, if you have an extra weight on the plank, then you would have to draw a new diagram because all the dynamics in the previous diagram doesn't quite work the same, unfortunately. So we're gonna copy and paste the same thing. So I'm just copy and paste as in draw again. Okay, so part B, suggest you draw again. So question B. Okay, so here's my diagram. Let me bring this down. Okay. Right, now the question is, the problem is RC and RD same as 12 and 8? The answer is no. When you add an extra weight on the plank, then the support will naturally provide more support force, right? Provide more reaction force. Because otherwise, if the support force reaction forces are not strong enough to withstand the forces on the weight on the plank, then the plank will just collapse and crumble. So therefore, when you have new weight, anything new added on a plank, everything has to be done completely again from step 1, right? So let's draw a cat. So where's a cat then? Cat start from the center of the plank and walks towards A. How far from A is the cat when the plank tips? Now, you tell me, where would you put the cat on the plank so that it starts to tip or start to tilt? Where do you think we should put a cat on this plank from A to B? Around roughly where? Then the plank will start to tilt. So it starts from middle, okay? It starts from middle. There's a cat. Yes, there's a cat. Look at a mouse. Anyway, it's a cat. If I put a name on it, it's a cat. Now you can't say it's not a cat because it's a cat. It's a name. Start to move towards the left-hand side. I believe when a cat is somewhere between C and D, it will still remain the same. But as soon as the cat starts to move beyond C, maybe somewhere here, then it starts to tip. It starts to tilt. In what way? About C. So D will be lifted off again. So it will be still Newton. Okay, so what we know is RD is still Newton. So let's say the cat is now here and it has a weight of 40 Newton, so 40. How far from A is the cat? So we can let this to be X meters. Right. So we've got our station set up. It's time to do the maths. Step 1. Upward force equal downward force. Now, RD equals 0, so upwards only RC, downwards is 40 plus 20 equals 60 Newton, which makes perfect sense because if RC is the only support force supporting the weight of the cat and the weight of the plank, then surely RC has to give at least 60 Newton back to the plank to support them. Okay, if RC cannot provide 60 Newton because of its material, then the plank will just break. All right. Step 2, take moments at a point. We'll take moments. Maybe we can take moments at A. Moments. You can take any other point The reason I take A is because X meters away from A. If you want to take it C, you can, up to you. Okay, take moments at A. But when I choose A, then I'll do 40 Newton, I have to do RC, and I have to do 20 Newton. So 40 Newton moment equals 40 times X, which is 40X, and that's anti-clockwise. RC moment equals RC times the distance 0.4. Now I know RC is 60, so it'll be 60 times 0.4, which is 24, and that will be clockwise. No, hang on, would it be? Or 40 Newton, 40 will be clockwise. And the 60 will be anti-clockwise, I believe. Yep. 20 Newton moment equal 20 times the distance away from A is 1 meter, so it's just 20. This time it will be clockwise. Step 3, clockwise moms equals anti-clockwise moms. Clockwise is 40x plus 20, anti-clockwise 24. So if you do the math, 40x equals take away 20, that's 4, divided by 40, x equals 0.1 meter. Therefore, the cat is 0.1 meters away from A for the plank to tip. Okay, right. Is that it? Yes, I believe that's it for chapter 4. So I hope you understand about everything about tilting, about everything about moments. That wraps up everything about moments. So you need to learn everything about moments in so basic ones like basic ones are part A, and then you have non-uniform planes, and also you can have tilting. So that's all they could ask you about in moments. All right.